Notes on geometry, special right triangles. We have two special right triangles. The first one is the isosceles right triangle. If the side is 3, then the hypotenuse will always be 3 times the square root of 2. It doesn't matter whether the side is 5 miles, 5 meters, 500 miles. The hypotenuse will always be the side length times the square root of 2. Well, what if they give you a hypotenuse of 10 times the square root of 2? Isosceles right triangle, we know that the side length is equal to the hypotenuse divided by the square root of 2, or 10 in this example. Of course, they may throw you a curve by telling you that the hypotenuse is 8. And they want you to find the side length. Well, what do we know? We know that x squared plus x squared equals the hypotenuse squared. When it's an isosceles right triangle, it's 2 times x squared. We can now divide both sides by 2. The square root of the square root of x squared is x. The square root of 32 is the square root of 32. But wait, look at this. 32 is 2 times 16. 16 is a perfect square. 4 times 4 is 16. The square root of 16 is 4. Another way to solve the problem is to notice that 8 divided by the square root of 2 is going to be x. 8 times the square root of 2 over the square root of 2. I can to get rid of this nasty radical, 8 over the square root of 2, I can multiply times the square root of 2 over the square root of 2. This is 1. Doesn't change the value, but it makes it a lot prettier. Then gives me 8 times the square root of 2 over the square root of 2 times the square root of 2, which is just 2. 8 divided by 2 is 4. Dude, check it out. If you have an isosceles right triangle, your side length is going to be the hypotenuse divided by the square root of 2. Here's all the fancy math that proves why it works. You may not be interested. You may simply want to take the hypotenuse and divide it by the square root of 2. That's the isosceles right triangle.